have we got a surprise for you. We are going to welcome digitally, not twinly, Anand, I hope I'm saying this right, Mecheri, and we're going to be looking at new revenue streams. So please welcome Anand.
Thank you. Thank you for having me. Delighted to be here and speak to you today. I'm normally based in Dublin, today in Dubai. Delighted that I can actually be virtually present with you all and share what I want to. Before I get started, just a couple of words of introduction. I am a technologist. I've been in the realm of smart buildings, digital construction, and digital twins for a good 33 years, always as an entrepreneur. Before I founded Invicara, I built a number of businesses around the smart building space. One of them, the claim to fame for one of them was that we created the industry's first, one of the first, I must say, smart building control systems that used web server technology back in 2005. I sold all those businesses to Siemens, was part of the global headquarters of Siemens in Switzerland, the building technologies business, and then founded Invicara. So Invicara, briefly, we are the developer of a platform called twinit.io. It's a platform that enables the AEC industry to create highly customized digital twin solutions. And you will hear the term composable from me as we go. And I'll also share why it is so important. As a keynote speaker, I'm not intending to be talking about Twinit and its capabilities today. That's for another day. If someone wants to reach out to me, please do, and we can talk about it. What I do want to do today is to share some of the understanding and knowledge about the industry and the opportunities it brings, and some of the motivations that led to us doing what we do, which hopefully would give you a little bit more context. The next 40 minutes, I will be walking you through a few topics. Christina already outlined quite nicely what a digital twin is for the built environment, and I would like to add a little bit more context to it and nuances to it. We'll talk about what problems it solves. We'll talk about the data problem and how do you make the data contextual and meaningful in digital twins. We'll also talk about the journey. How do you get from A to B in the digital twin world? We'll talk about the waypoints from extending BIM to a twin. And of course, we will also cover specifically what the opportunity is for the industry today, and who is best placed to harness that, and how will they do it. So that's the next 40 minutes. Look forward to that, and thank you for your patience and your interest in joining me in this session. So quickly, it is not. I can't overemphasize how important it is for the industry to have a common understanding of what a digital twin is, especially for the built environment. And why especially for the built environment? Because it has certain nuances which the other industries do not have. So if you consider Tesla, or if you consider GE and their turbines, these are manufactured products, right? They may have hundreds of thousands of them or tens of thousands of them built and physically built and available, but the twin represents a very standardized product. In the built environment, there's nothing standardized, right? So everything is bespoke, every building is unique. Not just that, every building type has its own business model. You could have owner-operated and occupied assets. You could have somebody owning it and somebody operating it, or somebody renting it. The maintenance processes could be completely different. The technology landscape is different. There's a huge amount of variances around how buildings are built and operated. And that brings a certain complexity to it. But it is all about eliminating the complexity and making use of this environment, the digital twin opportunity to create revenue streams. That's the conversation piece today. So what is the digital twin in the built environment? So as Christina mentioned, it is a virtual representation, no doubt, with the data relating to the process, whether it's in design, construction, or transaction, or an operation. So it is not just about operations. Digital twins play a part in every aspect of how an asset is developed, transacted, or operated. It is always scoped to the needs of the solutions it supports. And this is the nuance that I would like to add. Try and separate or distinguish between a digital twin and twin-enabled solutions, right? There's a slight nuance to it. Now, the reason for this nuance is that there are a number of solutions that can be digital twins. There can be a number of solutions that are twin-enabled. You don't want to rebuild the digital twins for every one of these solutions. So let's take an example. If you talk about operations of an asset, there is maintenance, there is energy management, there is space management, there is wellness, there is asset management. There's a number of different solutions that you need when we talk about operations. Operations is not this one thing. It's not just one piece of software or one process or one stakeholder. There are a number of different people involved. So when we start looking at digital twins as a twin that represents the built asset, the twin is scoped in terms of data to enable solutions. And the solutions themselves are use case specific. The solutions themselves are composed to deliver certain capabilities based on the roles of the people involved, the workflows they're involved with, the interaction they need to have with the systems. So they have their own data extensions. Solutions have their own data extensions. This could be in some cases, it could be dynamic data. It could be data from BMS systems, IoT sensors, dynamic information. It could be telematic data. It may be data relating to traffic on the streets when it comes to urban twins and smart city solutions. So digital twins and digital twin-enabled solutions are closely related but distinct. And we need to keep this in mind, in my opinion, to make this more tangible for people. Another important aspect that I want to surface is that digital twin solutions are not ideally built by software companies, okay? Digital twin solutions are built by domain experts, those who understand and participate in the business process, who can deliver a solution, who can compose a solution, and they need to have the ability to compose it, and we'll talk about it. So they can then create new digital services and add value to their existing engagements with their clients. There is software required for it, but the software should be ideally enablers for the domain experts, rather than creating a product that you ask a domain expert to resell. That's not what a real digital twin solution. That's not the real potential of a digital twin solution, right? So with those sort of context in mind, let's walk through a few more pieces of the puzzle, right? The first step is, when we talk about solutions, we need to talk about use cases. A digital twin enabled solution means that it is targeting something very specific. If it is urban planning, obviously there are a set of use cases around that. If it is design, analysis and simulations, it could be construction related, it could be transaction related or operations related, whatever it may be. The use case needs to be up front and center. It needs to be established based on the use case that solution is going to, or a set of use cases that a solution would address. There needs to be a well-crafted requirement for the information that will enable that use case. And this information also defines the data sources. Where is that information going to come from? Who is going to produce that information? At what stage in the project, if it's a new development, what stage in the project will it be produced? How will it be collected? How will it be validated? How would it be organized? So starting with strategy and planning, starting with the end in mind is a bit of a cliche, but it is super critical when we talk about digital twins. So that's the first step, making sure we understand the use case. We also talk about BIM in this context, because in most new developments today, BIM is a default, right? If it is an existing asset, maybe not, but that's another scenario we will talk about later. But if it's a new development, as Christina also mentioned earlier, BIM is a fantastic way, a fantastic starting point for us to get some of the information that we are targeting for delivering those use cases. Now, BIM is absolutely useless if we did not address the data workflow. If BIM is all about producing 3D geometry, coordinating the different disciplines and producing drawings, that definitely is powerful from a construction perspective. However, from a digital twin perspective, the models need to be machine readable. Machines or systems need to understand what is what in that model, what the information about it. So there are three important aspects of model data workflows that one needs to keep in mind. The need to classify models correctly, the need to define the data requirements correctly, and the need to validate the data that is produced by the different stakeholders. We refer to as Invicara, as we went down the digital twin journey, we realized that if you don't provide the tools to the industry to do this, we're going to get, from a data point of view, absolutely useless models. And it's going to be more painful to heavy lift the data post facto rather than producing it as part of the process. So we built what we refer to as model data management tools in order to support the creation and validation of the data through the BIM process. And I'll probably show you a quick sort of a demo of how easy it is to actually do these classification concepts. Once we have that, once BIM is set up as a foundation with the focus on the data, then we need to talk about twinning the world, or twinning your world, the world that you are helping create. It could be a building, it could be a commercial building, an airport, a hospital, a data center, energy infrastructure, water infrastructure, a smart city, whatever may be your world, that will need to be twinned. Now, to twin the world, you need a lot of different actors. You need geospatial data. You need maps and geospatial data represented on those maps. You need 3D models of buildings and infrastructure assets. You need a lot of field collected data sets, commissioning data, testing data, operational data such as inspection information, IoT data coming from the field systems that are producing that information, informing how the asset is performing. And these may be represented in 3D viewers or with no graphics, just data, analytics, and dashboards. It could be immersive game world experiences, such as a pixel stream from a game engine like Unreal or Unity. It could be a photosphere. There could be drone scans. For example, if you're building an application for tracking construction progress monitoring, you probably need to integrate drone scans and photogrammetry. So there's a lot of different information that needs to come together. What would we focus on? The answer is very simple. You focus on the information that's needed to drive your use case. So if it is the building, if it's about operations, you focus on, and if it is within operations, if it is maintenance, if it is energy management. So we think about the use case and then decide what should we include in the world that you're twinning. Once you've done that, you then have a twin that can enable solutions. And we'll talk about solutions in the context of design, the context of build, transact, or operate in a minute. But the core is that you've created a twin that is represented as a knowledge graph. And we'll talk about that as well as we go forward. Now, I would like to give an analogy to this. Right? If you look at a great example of what you're seeing here on the slide is actually Google Maps. Now, there's a big difference though. Google has twinned our world already once, and they continue to improve it and update it and maintain it. And then there are others building solutions on it, whether it is navigation or whether it is planning a holiday and finding a place to stay, or planning your dinner tonight, or it could be about public transport, planning your transportation. So all of those are applications. So the bubbles that I have on the right side look different. It may be navigate, it may be travel, it may be whatever. But those are solutions built on top of a twin. But in that world, in Google's world, they have already twinned our world, and in a certain context. They've not twinned everything. They've twinned the world in the context of those solutions that are built by them or somebody else, but we're all using it. In our world, in the built environment world, you have to twin the world. Somebody has to twin the world. So we'll talk about again, who's the right person to do that. But obviously it is the domain experts, the engineering companies, the construction companies who are involved in the process of creating the physical asset are best placed to twin the world and create that capability to implement solutions. Now, obviously, they can be implementing the solutions themselves, but they're not software companies, right? So So how do we do that? So there are solutions, and we ourselves have implemented a platform which is meant for engineering companies, but of course with some ability to do scripting, they can compose solutions or create solutions that meet the business requirement, the use case of the customer, but also address it in the context of the business model that they are bringing together. So this kind of tells the story about how we start with the end in mind. We start with the use case definitions. We then use that to inform the information requirements. We then use that to inform the BIM process. We focus on the data workflows. We classify, define, validate the data. And then we make use of all of that together with various other data sets in a digital twin platform to twin the world that you are focusing on, and use that to build solutions. So when we don't decompose digital twins like this, and when we just talk about digital twins, it tends to be many things to many people, not understood. But when we break it down, it actually starts making sense. So what are the solutions? So what solutions are we talking about? Now, if it is design, there could be solutions ranging from urban planning applications, or it could be producing highly carbon optimized designs, or it could be about energy optimized assets. It could be comfort optimized services as part of the building. So a lot of these simulations and analysis tools exist today, mostly standalone, but there is an opportunity to integrate them into the digital twin thinking, so you make the data more transparent and more leverageable across the life cycle. Likewise, during construction, there are a number of processes and workflows that we today execute. There's a lot of productivity gap, and many of them can be addressed through a digital twin in a more efficient way. Now, there is still a lot left to be done here, right? So it's not that today we have a digital twin platform that supports numerous solutions that are pre-built and usable. It is still a case of an evolving landscape. Now, what we find very attractive is that large asset owners, asset developers are able to create solutions that bridge the gap between their current information management systems for construction management and their expectations and goals around some of these processes and workflows. But it doesn't stop with design construction, and it doesn't have to go straight to operations. There is this important step in between, which talks dollars, right? Which is the transaction piece. How does the asset owner attract and engage the different stakeholders in respect to their development? So enabling visitors, occupants, and investors. We talk about multimodal experiences, because some of these applications or twin-enabled applications may use GIS data and maps. Some of them may use immersive 3D game world experiences, or it could be, in some cases, 3D models as well. So enabling the stakeholders to interact with the twin and focusing on specific services is what generally the industry has started calling smart destinations. And this is becoming really popular when it comes to creating new assets, smart city type developments. And there's a lot that's going to be created in this space, as we all know. Likewise, engaging the occupants, engaging investors, building communities, and improving business processes. So imagine I have a campus development, or I have a large city square development, and I want to enable my salespeople to actually go have conversations with investors or tenants or prospective buyers, and give them an experience of how exactly this asset will look like, know which asset is available, what is the information about it, all of that on their laptops or on their tablets. That would be very powerful as well. So we can enable, digital twins can enable business processes. Likewise, in operations. In operations, it may be about attracting investments. Now, ESG is a big term for every type of asset, not just commercial real estate. Even for universities and airports and healthcare facilities, they have to have a good ESG rating for those assets and the companies who own those assets to be investable. So that's a huge focus, and that's a huge value that we can bring through transparency and trust through a digital twin. Occupant comfort, again, a major topic. Every large corporation realizes today that their biggest value is the productivity of their employees. And how do you make sure that that happens? And when that happens, there's clearly higher rental yields. There is also around the topic of reduced capex. Now, how do you make sure that you use data to drive decisions around when do you replace a piece of asset, how long do you keep maintaining it, what is its life, and so on. So you can use data. Digital twins can provide that, do some simulations, give you projections, what you can do with it. And likewise, analytics to give predictive maintenance, to enable you to do predictive maintenance, reduce energy usage. So there's a lot of different benefits that can be accrued through solutions. Now, not everything is done by everybody. Today, our company is working with engineering companies, contractors, strategy consultants, urban planners. And each of them are approaching the landscape in a different context, in their own context, right? So somebody is looking at one specific domain where they play in, and looking to see how can they leverage digital twin technology to improve what they are doing and improve the services that they deliver. So this is the overall landscape. Now, every company has to choose and make a decision, what is their segue into the digital twin world and how are they going to leverage it for their own business. Now, there's obviously a lot of different data sets we talk about, right? And this is really important to touch upon. Now, the data sets are a lot of data. Data is good, right? Don't get me wrong, but a lot of data, if it is not organized right, it is garbage, because you can't really make any sense out of it. We just spend a lot of time to collect the data, a lot of time to validate. Everything goes into this, either this big spreadsheet or it goes into this hard drive with a database of some sort. Little bits of it is extracted into an Excel sheet to populate a maintenance management system, and that's it, done. Everything else is wasted. Now imagine when we collect the data, and I like what Christina said earlier, be minimalistic, focus on the things that you care about based on the use cases, but get it right. And that's really the storyboard. But when you get it, it needs to be organized. Now, what you're seeing on the screen here is what is referred to as an ontology. An ontology is a domain-specific data model. So this is a data model of a building, let's say a commercial building. And this building, what it says is that there are many buildings in this campus. That building has a number of levels. In each level, there are a number of rooms. The rooms are composed into zones for the various services. In respect to the HVAC, these rooms are served by zone 1. That zone 1 is served by this system. And these systems are made up of these equipment, some upstream, some downstream. So which equipment feeds the other, which equipment is located where, which room is part of which level. And again, sensors, what information is produced by these equipment and what capabilities does it have. So this simple data representation allows us to collect the data, organize the data, and produce what we refer to as a knowledge graph. The knowledge graph is what every social media platform uses. I think Google introduced it in 2013, I think. It's not a very old concept now, but very powerful because it allows us to represent all the entities we care about. Now, what we talked about here are the entities. And these entities can also be process-related entities, data produced in an operations workflow. Maybe nothing to do with the services. It may be about a healthcare facility and about number of people sitting in the waiting room. Maybe occupancy information. It may be the throughput of a diagnostics machine. It could be data that is relevant to the business process or the use case that we're trying to address. In an airport, there could be several use cases that helps the airport to bring people from the curb to the gate very, very quickly, and how to leverage and maximize the revenue that they can produce in the process. Now, a knowledge graph like this essentially allows the solutions, the twin-enabled solutions, to query and collect the data that it needs, or bring the contextual data together to drive the user interface and deliver a value that is being targeted. So what are the waypoints? Now, if you talk about BIM, so obviously we've got to start with the use cases. We've got to think about what are we trying to solve? And once that is done, you define the information requirements, and then we focus on the data workflows. The data workflows are crucial. I have an example. In fact, we were in conversations with AMCA and BIM MEP, and we're delighted to see the VBIS classification system. And more than the classification system, we're really happy to see the effort you're putting in to define the data requirements for each class. And that's very powerful. We can actually now codify all this and productionize it for you. So which means you can easily produce this information to classifying, defining data requirements, gathering the data, validating the data and the documents. And then obviously you got to bring all of this into a platform. The composability of the platform is critical because Again, as we talked about before, every client is different. Every use case will be a little bit different when applied. And there needs to be a capability to compose the data model, the data sources, the business rules, the user interfaces, such that you can actually deliver something that can be used, meaningfully used. And it is not a BIM-specific data model. You need to be able to extend the data model to include various other data sets. So doing that sets the stage for building the knowledge graph that you saw, and then use it to build use case specific solutions. These use case specific solutions, again, have to be composable, because if again, let's use the operations example. For a maintenance technician, when I log into the system, what I want to see on the homepage will be very different from what the C-level wants to see on the homepage. The C-level probably wants to see across the whole portfolio their sustainability metrics, right? But if it's a maintenance technician or a building manager, when he logs in or she logs in, they want to see, what's most relevant to their function within that organization. So the ability to compose solutions is very powerful. And again, for the solution provider, as a contractor or as an engineering company, there is incredible value in doing that, where you can create expert views that you can remotely access. And we'll talk about that in a minute. And before I go further, I want to show you very quickly, how easy it is for you to apply proper classifications to the models. Now, one of the challenges we all have is, how do you make sure that the design firms on a project, or contractors on a project, subcontractors on a project, all of them produce models and classify everything consistently? Something which walks like a duck and quacks like a duck should be called a duck and not a goose, right? So how do you do that? So this is a good example of that. I asked one of our team members to put together a workspace called AMCA and set up the VBIS classification system. And as you can see here, using Revit, they have set up a workboard. They're looking at, they're selecting a piece of pump and want to classify that. And using a Element browser, the user is also selecting a few other pumps that they want to classify right now. It's filtered out everything that is not in the model. It's not a master list. And once he's got the workboard, he's calling a friend, essentially clicking a button to say, tell me, what should I classify these things as? And he's got the answer. Classify that pump as EBIS, MEPU, CIL, centrifugal, whatever. So he's got the recommendation. And what does he do? He simply accepts the recommendation. And once he's accepted the recommendation, if you look at the element, it creates those parameters within the model. And within those parameters, as you can see, it has created those parameters and it has added the values directly. So you're productionizing the process of classification. Likewise, once he has done that, you go in and say, I want to get the equivalent unique class and omni class values. Likewise, call a friend. It goes back immediately, the equivalencies come in. Once the equivalencies come in, you accept it. Like in the earlier case, all those 10 elements were classified, look at the properties, and there you go. You got your equivalencies populated. Now, when we start thinking digital twins and we start thinking about data workflows seriously, the technology is there. We just have to now start implementing it and making it more consumable. Now, so moving on, so what opportunity does it bring, right? What really are the opportunities for mechanical contractors or engineering companies? So there are two types of opportunities. One is your new build. I'm not talking about urban planning now. I'm not talking about the design workflows or transaction-related opportunities. I'm just trying to filter it down to saying, okay, the audience today are mostly in engineering or construction of buildings, and they are mostly in new buildings, and maybe they're involved in supporting some existing assets as well. And definitely they've created a huge body of assets that are out there crying to be taken care of. So if it's a new build, what's the opportunity? So every asset you're building now requires some outcomes. It requires a digital information handover, right? We all know how bad handovers tend to be, how poorly structured they tend to be. Getting the handover asset information properly structured and delivered as an asset twin is a valuable service for the asset owner. And without question, more and more asset owners are beginning to actually ask for it. But if you can take the step forward and offer it, I think that's a great service that you can bring to the table and value add. The other is about digital witnessing. So many times when the systems, technical systems get commissioned, they all get managed individually. The BMS systems work great when they are commissioned, but very soon things are drifting. Somebody complains, somebody changes the set point, changes the schedule, changes a damper position or whatever, and very soon everything is out of whack. So how do we make sure that there is digital witnessing happening by integrating into all of the data created by the real-time systems and doing performance validation? So that's something you can do, which creates this, what we would call a performance twin. A performance twin, I would define it as a rich asset twin, which is integrated with performance data. So that is one possibility. So in a new build, creating a digital asset, creating a performance twin or an asset twin, depending on how much you want to extend your scope, is a service that can be remunerated by the client, because it is something that adds value to the project. Likewise, you have a lot of existing assets. You have helped build so many assets, right? And those assets are part of a portfolio, and those other buildings in the portfolio probably also suffer the same problems. Now, with the ESG focus and the client's needs to, the client's desire, the asset owner's desire to optimize the performance of the asset, improve the energy performance, improve the wellness index, and so on, there is an opportunity to do that. Now, you don't have to do 3D modeling, right, for an existing asset. You can build a data foundation. You can build a knowledge graph of the entities and the relationships. If need be, you can build a what I would call a minimum viable 3D model, either from drawings or using scans or just photographs as reference to build that. Retro commissioning, the equivalent of digital witnessing in an existing asset is retro commissioning. Same thing, validate the data, and bring it together into a performance twin. So again, but probably no one is going to do the existing assets piece without a purpose, right? Whereas in a new build, handover has a value by itself. Whereas for existing assets, if somebody wants to do this, and that is because they want someone to bridge the gap between the asset owner and the facility contractor. This we see universally as a huge problem. Asset owners have increasingly high expectations out of how the asset is going to perform. Facility maintenance and contractors are not necessarily all stepping up and understanding how to use data. Whereas engineering companies and mechanical contractors understand the physics behind the systems, understand the engineering behind all of the infrastructure that has been put in. Now, if a digital twin solution can facilitate them to do remote monitoring and management, they can help bridge this gap by providing what I would term technical infrastructure management, which includes predictive maintenance, diagnostics, helping with capital planning or occupancy and improving space utilization by tracking occupancy, improving comfort, and also identify measures that can be implemented to reduce the energy consumption and improve the carbon footprint. Sustainability reporting is huge. So there is an opportunity for mechanical contractors and engineering companies to leverage twins, even in commercial or residential buildings where you have an asset owner who wants to optimize its performance. New construction could easily result in a deliverable, in a performance twin or an asset twin. Existing assets can be twinned as well, with or without 3D models, but both of them can become your universe to start delivering these new services based on remote monitoring and management. So in summary, who's going to do this? We talked about it. Digital twins, in our opinion, are best built by industry practitioners who are experts, who know the physics behind the systems, who know the problems that they need to solve. And of course, only if they wish to create new digital services. And we are seeing the race has started. And obviously, my goal today was to try and incent or inspire some of you to think in this direction as well. Clearly, twins are built on platforms. Like, not all platforms are equal. You definitely need a composable platform if your aspiration is to progressively evolve your digital services, because that gives you the ability to create those solutions and become the digital company built on top of the domain that you know very, very well. Now, you could also use solutions that are repeatable. You could also build these solutions They become your intellectual property. Obviously, there's a lot of knowledge behind behind how to optimize the performance of a chill water system or a heating system or a certain plant type. Now you can transform all of that into knowledge and into solutions and effectively use that as your IP to generate revenue in the future. Again, some of these solutions are also available as package solutions so that you can simply customize. It diminishes your flexibility. Composing your own solutions requires the highest level of skill. That would mean that you need a little bit of programming capability within your organization, at least to the extent of doing data modeling and writing JavaScript to compose those solutions. But if you don't want that, and you prefer to use a prepackaged solution, then which you can customize, that would be your next alternative. And customizing a solution is key because, again, as we talked about, every client is different, the data requirements are different, the use cases are different. Or the easiest, of course, is to resell a product. Somebody has pre-composed, probably a software company, has built a product that has a set of workflows, fixed schema, fixed set of UIs, and you effectively try and fit that product into the need of your customer. So that is the a summary of how a digital twin enabled service could play out for yourself.